Good morning to all the panels, Dr. Hadley, Dr. Muhammad, and Dr. Kamil. My name is Vikram Raj, and my metric number is B051710040. First of all, I would like to thank all of y'all for allocating your time for this presentation. Without wasting any more time, I would like to get into this presentation. As you can see from the slide, the supervisor for my project is Professor Dr. Shuko, and he is the one that been guiding me throughout this whole experimental project. The project that I've chose for my FYP1 for this semester is optimization of machining parameter for milling operation of carbon fiber reinforcement polymer, which is also known as CFRP. This is because I felt that CFRP has a lot of advantages where carbon fiber is used for aerospace, aircraft, automotive, sports equipment, and medical equipment. But in order to accomplish required shapes and dimensional resistance, machining parameter and process of composite is very important. How do we gonna cut this material, CFRP? The answer is milling process. Milling process is very suitable machining measures in composite manufacturing with the goal that great and high quality surface are achieved. But in But the surface roughness is all dependent on cutting parameter tool calculation resultant machining power. The machining parameter involved in these experiments are there are three things, which is cutting speed, feed rate, and depth of cut. Milling has a lot of types, and the one that I chose to conduct this experiment is face mill. A face mill machines a flat surface of the workpiece in order to provide a smooth finish. The depth of the face, typically very small, may be machined in a single pass or may be reached by machining at a smaller axial depth of cut and making multiple passes. And the material that I've chose to conduct this experiment, as you all know, is carbon fiber reinforcement polymer, which is also known as CFRP, which where it composed of carbon atom bonded together to form a long chain, and it also a super strong material which is extremely lightweight. And most importantly, CFRP is regarded as having superior properties. After conducting all the after going through all the journals that and articles previously, the studies has shown that there are few problems that have been identified. Firstly, incorrect cutting parameter. If the cutting parameters such as feed rate, spindle speed, or depth of cut are too deep, the surface of the selected workpiece will be rougher than the desired one and also may be contain scratch mark. Secondly, the large depth of cut may be result in vibration of tool and causes inaccurate in the cutting process. Other than that, cutting tool is also the one of the defect in milling process. As a tool is used, the sharp edge will be wear down and become dull. A dull tool is less effective of making precision cut. As for the objective of this study, there are three. Number one, to study the effect of machining parameters such as cutting speed, feed rate, depth of cut on the surface roughness of CFRP. Number two, to evaluate machining parameter to produce the best surface finish. And finally, to measure the result obtained that contribute to the machining parameter on the surface finish. As for the scope, for this project is the literature survey, and the details are all about milling parameter, tool bit, and the chosen material, which is y'all are aware: CFRP, milling process, surface roughness, and milling. There also contain milling machine purpose and also the comparison of surface roughness of CFRP. As for the as you can see from the slide, literature finding, there are tons of lots of journals and articles that I went to conduct this experiment, and as you can see from the slide, these are the main three journal authors that I have chose to list down. Where these three journals are very important tools that I got to conduct this experiment. Where, as you can see from the first table, is our author is Yong Fing Ho, where he published his article on year 2013, and from his journal, which is a milling process, I have a lot of information that I've gained, where cutting tool, remove the allowance and form the machining surface, and various types of milling cutters are defined by giving different values. And this is the information that I got from his journal. And moving on to our Jing Hao Zhang, where he also published his article in the year of 2013, where in this article it's all about the information that is milling process parameter, where selection of cutting parameter has a direct effect on machining quality, machining efficiency, and the tool life. And as you all are aware, the process has three parameters: cutting depth, feed rate, and spindle speed. And finally, our Victor Riado, where he published his article in the year of 2019, and it's all about material. Class by CFRP has classified as difficult to cut due to the presence of hard fiber, and it also can be manufactured following different manufacturing method. As for the literature review, as I mentioned earlier, a lot of literature that I've went through, that I've studied, looked into, and I have looked at the fundamental of the milling machine and discussion on the machining parameters. Secondly, there are lots of types of milling machines such as end mill, tapping, drilling, and face milling, and I chose face milling process to study the effect of machining parameters such as cutting speed, feed rate, depth of cut on the surface of CFRP. Not only that, after getting into this all the journals and going through all these journals, I also get to know what is face mill all about, where face mill machines a flat surface of the workpiece in order to provide a smooth finish. The depth of the face, typically very small, may be machined in a single pass or may be reached by machining at a smaller actual type of cut. Besides that, I also got to know I also received a lots of information on CFRP, where CFRP are class of extremely strong and lightweight fiber reinforcement polymer based on carbon graphite fiber. Besides that, CFRP offers a very high strength to weight ratio, high modulus to weight ratio, high damping capacity, good dimension stability, excellent damage tolerance, and good corrosion and fatigue resistance, which makes them widely used in aerospace, robotic constructions, and etc. After reading few journals, there are a lot of methods that I have conducted to study this experiment. So the best sequence of operation that I come is on the slide, where first we have to check the serviceability of the milling machine and lubricate according to the maintenance schedule, and then we have to select the speed and the rate of feed and set them accordingly, and then we have to clamp the workpiece so that the material to be removed always project above the highest point of the world holding fixture. Thus the work holding fixture and the milling tool are protected against damage, and then scratching has to be done by the milling cutter with the running speed is brought closer to the workpiece surface so that the scratch at the highest point of the surface, which is not machined yet. And then following, the required depth of cut is adjusted and the surface is roughly milled. After the machine table has been retracted to the starting point, the specific size is checked. Independence of the machine tolerance is existing. The second milling operation is conducted, and after that, the finished surface has been. If after the finished size has been achieved, the workpiece is unclamped, deburred at the cutting edge, and checked for the plane accuracy to the size. And after all the inspection is done, we have to clean the places where the milling machine tools and clamping testing tools, and the workplace has to be cleaned. So as you can see, this is the flow chart where we have to purchase it, we have to purchase, and then we have to receive the material, and if it's not good, we have to start all over again, and until we satisfied with the product. And if we are satisfied with the product, we have to prepare the material, and then we have to pre-machining, and then we have to experiment in three categories where cutting speed, feed rate, and depth of cut are involved. To conduct this experiment, the method that we're using is milling machine, and after that we have to come into a conclusion and give a best recommendation to name which cutting speed, feed rate, and depth of cut is suitable to have less surface roughness in this on the material of CFRP. Thank you, doctors. That's all from me. I hope you looked into this presentation. Thank you for your time, Doctor, once again.